So before we start, do you have any questions where we left yesterday? No.
Sandeep, again, the one concern that I have is like I understand this binary search method, but I guess using it in the practical environment, it's like how to identify a particular problem can sort it through binary search. It's a bit hard to grab on at this point.
Yeah. So my honest suggestion is, okay, even though I'll try to explain it, okay, and I think that I'm good at explanation, but honestly speaking, that doesn't work. Okay. What works is solve at least say 5 problems with binary search. Okay. And then teach me how to explain it. Okay.
Uh, okay,
Okay.
next. Yeah.
What?
I might pick some problem from lead code or somewhere else.
Yeah. Yeah. Solve it. Solve, say, five to 10 problems. And trust me, it is essentially a muscle that you build. The more, because it becomes very difficult, even though, let's say, I'll explain that just like a square root problem, okay? When you jump to the middle, if you can identify whether to go left or right, that means it's a binary search problem.
Yeah.
Okay. And if you can't figure out that you can go to left or right, meaning you cannot half it, you cannot reduce the search space to one half, that means it is not a binary search problem. Okay. There are many, many more problems that can be solved with binary search. We will see that very soon. Okay. And there are many variants to that problem. Okay. Many variants to that problem. Okay. Uh, the clear relationship is, let's say, let's take more problems. I think the more problems you take, the better it would be. Okay. So where is our folder? Yesterday's folder. Okay. This one. This was yesterday, right? Everyone keep your cameras on. Okay. I want everybody to pay attention rather than sleep off. Okay. Even if you're sleeping off, it's okay to sleep on the camera. Okay. All right. Yeah. Yeah. Question from Srivatsa is that I'm new to the course. Can I know where are we currently? Yes. So where are we currently? We learned about right. Can somebody summarize what all we learned? Let's see who all can remember.
I think we learn the basics. I mean, basic coding. We learn about loops, iterations, and conditions. We learn about arrays.
Yes.
We learn about recursion, and we are now learning this searching algorithm.
Yeah. So we talked about statements
No.
and if-else statements and variables, if-else, then loops, right? And so on. Okay. And functions and recursion. Okay. Then we talked about binary search. Okay. So yeah, this is where we are. Today is June 8th. All right. Perfect. Perfect.
Number system.
Yeah, we did number system before that. That I think I'll call it number system.
String also.
String also, yes. Right. the arrays and strings. All right. So yes, and my request to everybody would be, even if you are acquainted with Python, even if you are acquainted with coding, do the exercise, the one that we are talking about in the class. Like, for example, yesterday we talked about the order of complex, not this one. Where are my question? Yeah, okay. Question number 1 was your binary search. Okay. We are right now in binary search. Those who are coming from maths background, we call that bisection method. And in case of Python, there is a method called bisect. Okay, that's for you. Okay, and which method has, I think collection has this method called bisect. Okay, bisect left, bisect right. Okay. What do you call this? Yeah, bisect. Where is this bisect? Is this a separate program? Bisect left, bisect right. Okay, so you basically have a method import from bisect import star. Okay, but don't use it, code it. Okay, let's say, okay, so here it is telling us that the 4 has to be inserted at the position 3. Here, 0, 1, 2, 3. Okay, so if you have more 4s like this, it would say 0, 1, 2, 3. Okay, that's called bisect left. So it quickly searched for a position where to insert 4. Okay, so all right. So in the beginning of the course, what we focused on is creating our own number system. Pick a base 10 or base, no, not base 10, don't choose the base 10. Choose a base, say 13, 14, 20, okay? Or you can say choose number of symbols, okay? Let's say you choose alpha, beta, gamma, or you choose square, rectangles, and something. Choose those many symbols, and using those symbols, create your number system. Okay, and you're free to choose any symbols. Okay, say for example, somebody might want to choose triangle, circle, square, and asterisk. Okay, so using these, you can say, okay, my 1 is triangle, circle, square, star. This is 1, 2, 3, 4. And then you can say, okay, this is 5, then this is 6, and also. You can create your number system. And that's what we discussed in the beginning. Then we talked about if-else statement. Then we talked about the loops. Then we talked about functions and recursion. And then we talked about binary search. Okay, most powerful thing out of the entire programming are these 2 topics. Okay, so binary search is an algorithm where you basically do the guessing, a smart guessing. Say, for example, we did an exercise where we had to compute the square root of any number, let's say 10. So we went to the middle of 10, which is 5. Then we tried 5. 5 square is 25, which means that the number has to be less than 5. So then we tried 2.5. And then we kept on dividing the entire range into 2 and selecting that. Okay, so that was binary search. Recursion is a function calling itself. Okay. Now, these are two great ideas. And again, as I say, that don't think about coding as typing. Okay. So coding is not equal to typing. Okay. Coding is more or less equal to poetry. Okay. Or you can say philosophy. Okay. So the coolest ideas are in coding. And basically, when you do the recursion, when you do the binary search, you will find that coding is not typing. These ideas, such as recursion or binary search, they help us think. Okay, these ideas have helped me thinking. Honestly speaking, these two ideas is something. I mean, these are two of the all ideas that I learned that I did not know. I could not think in terms of recursion when I started. I'm being very, very honest, brutally honest. Okay. So, and when I looked at recursion, when I looked at the data structures and algorithm, and when I looked at binary search, I developed this internal respect to coding. Before I came to know about recursion, I thought coding to be something like, a very boring thing, something like, number of steps, and you can just, if you know the syntax, you can get it done. No, it's not about syntax. It's about idea. It's about this idea of solving problem. It provides you these constructs of thinking. Okay. So even if after these many classes, if you have any doubts about coding, I would, feel free to, reach out to me. Okay.
Sandeep, I tried to do it, do the binary search with recursion, but it didn't work for me. But with while loop, I am able to do it. Can I share?
Show me.
Okay.
Yeah.
I'll paste the code or share it.
Yes. Share your screen. I'm unsharing the screen. Okay.
Oh, okay. I'll share that.
And yes, only those will learn coding who struggle. Those who do not struggle, they will not learn. I guarantee this part. Okay.
Yes.
So the
I
struggle. Yeah.
I'll come back to you with a lot of questions after 2 weeks.
Okay.
The reason I'm saying 2 weeks because it's just one last assignment due for my MBA, and I'm done with that. So
Okay.
just focusing on getting rid of it, and then I'll be back to codes and whatnot.
Yeah. MBA is okay, like a good driving license, but learn to drive.
Yeah. I mean, it's the last capstone project is left. So I need to write 5,000 or 8,000 word limit assignment or something.
Yeah.
Just finishing that.
ChatGPT and get it done. I met these KPMG guys recently in last, and I told them on their face that all your presentations can be done better by ChatGPT than all of you. They were giving talks on generative AI, this and that.
Yeah.
Okay.
They gave like a lot of real. It's a real world problem. So we are actually working with some company called Cunningham. It is here in Australia, Queensland. So they got the people from us. They share their research notes and whatnot. So kind of chat GPT is there to help out like framing words and whatnot, but can't help us in like writing just taking up the entire notes and compiling that into 5,000 word limits.
So okay, maybe I'm showing my bias, Rahul. Okay.
No. You are right, though.
Yeah. My feeling is that MBA is putting common sense in big words. Okay.
Yeah.
And okay. Now let's take a look at this array. Array sorted, and we are looking for number. everyone, please pay attention here. Let's read through the code. So we are saying define search. Search is a method. Array is sorted. And we are looking for this number. If length of this array sorted is equal to 0, return false. Perfect. Which means if the length is empty, then the number is not found. Correct? Now, you are saying left is 0 and length of the sorted array -1, that is right. So you picked up left and right, and then mid value is left plus right by 2. Perfect. And then you are saying if array underscore sorted mid equals number, return true. Perfect. If the only thing you forgot is that putting return statement before search.
Oh, this thing
Yeah, that's all I think.
Okay, I was not getting this true or false.
Okay, just test it. Just test it. Yeah.
Okay.
Okay. Let's test it with one element first. First empty, then one element, then two element, and then so. Okay, so you are saying array sorted mid +1. If the array sorted is less than number, okay. Okay. Yeah, empty. Test it, run it. What
False.
does it say?
It's false. It is false.
False, perfect. Now, next, say 12. Just say 12 first. Okay, let's take a look at this one. So you are saying left equals to 0, right is 4.
It's not there. False.
Shouldn't right be +1? Why it's less? I don't get it.
Which one?
No, I'm just looking at your debug statements. Left :0 and right :4 and mid is 2. How many elements are? Oh, it's 5.5. Okay. So total 5 values. Right is at 4 and okay. Yeah, this is correct, right?
Okay, I was not getting this true or false. I was getting the array correct, but I was not.
Yeah. Basically, you forgot that return statement.
Got it. Thank you. I was
Okay.
struggling with that.
Just put 6. Just put 6.
Yeah.
Just test it with 6. Okay.
Yeah. This one.
Perfect. Very good. Very good. All right. Awesome. So because when you don't return, what happens is returns none and you're doing recursively. Is everybody clear about this code? Or you want to walk through the code? Anybody wants to walk through the code? Good. Very awesome. Very awesome. Anybody else has tried the binary search with recursion?
Yes, I did. I shared it in the chat. Yeah, it is similar to the previous one.
Okay. Abhijit, right?
Yeah.
Right. Search array n and left equals 0, right equals, yeah, perfect. Oh, this is good. Okay. Yeah, this is exactly identical to that one, right? Yeah. The only thing is here you should do array. Oh, anyway, you have done mid. Can you show me your code again, Veena, once more? Abhijit's code looks correct. Only one thing that is different. This is correct only. Yeah. Okay. And one more thing is okay. Okay. In the end. Okay, but there won't be any scenario, right? The last return false, will it have anything? Abhijit? In your case, will it ever reach that return false?
In case when we don't have a value, then I think it will go there.
Okay. Okay. Show me your code. Let's take a look. I mean, share your screen and then let's take a look. Okay. I'm just doubting. Okay.
Yeah.
Okay. Good, Shweta. Very good work. Left, right. Okay. So what you have done is you have put left and right. That's also very good approach. Is it working, Shweta, your code?
Yes, sir. It's working.
Good. Very good. Very good. I think you should show that code. You should also show that code. Can you go ahead and show the code? Abhijit, yeah. I'm just think about it. Is that return false needed in the end?
Okay.
Can you test it
Yeah.
out after removing it and then see?
Yeah.
Okay. Shweta, can you go ahead and let's talk about that one. Okay. And I
Okay,
want to
sir, I'm
compare
sharing.
your code with Veena's code. It's very important. I'm very happy that you guys are working so well. And this is essentially giving all of you different perspectives. Okay. Different perspectives. And I think yeah, and trust me, reading code helps a lot. Okay. I mean, just like, most of us learned English by reading lot of fiction books. Similarly, you learn coding by looking at lots of code. Okay. It actually helps, right? I mean, I personally can tell you that the more code I read, the better I got. Okay. Now let me take a look at your code. Okay. So this is your code. So binary search number. Yeah. So do you see the difference here? The difference is what she has done is instead of every time creating a new copy of the array, right? In the other, the code of Veena and Abhijit, what they were doing is they were taking the array and they were slicing it and passing the array again, which means they were creating a copy of the array again, right? Here, what she has done is she has done a pretty good job. So what she's doing is she's passing left and right. She's passing left and right along with the array and so on. So it's the same array. So she's not allocating more and more memory, and she's just doing taking the array. You see that? There's a cool idea, right? So instead of making copies every time, because here we were making copies, right? The moment you do the selection that give me only left side of array, right side of array, we were creating kind of copies. Okay. All right. Is it working? Tested it?
Okay.
I'm asking you, is it working?
Yes, sir, it's working. Let me check.
Yeah.
So,
The only thing in this is a common pattern, by the way, what Shweta has done. It is a very common pattern that you have a separate function called internal binary search number, where you're passing left and right, and then you have a wrapper called binary search, which will basically calls G with the left and right. Okay. So you can actually you can change the name of this function to underscore binary search. Okay. All right. And then define another function that calls this function with left and right. This is good. This is good. Yeah. Binary, this is your internal function name. Now define another function called binary search that takes L1 and number and then calls your underscore binary search. Okay. This is a common pattern, by the way. Okay. Define another function called a binary search. Okay. Say def
In the
binary.
above question, if we have the empty array, I think it will fail.
What?
If the array is empty, it will not go into a case.
Yeah. Yeah.
Then the first we search on the binary search top method, we can search is array is empty or not. Figure out the left or right first.
The right is equal to none.
One more thing. I did not understand. Left equals number. What does it mean?
Oh, that is if only one number, I guess. Yeah. The
So let's
condition I have
say
actually put.
so left and right is a position, right? Not actual number.
Oh,
L1 is the array, right?
sorry, that was one of the condition I put sometime. Like I've tested it sometime. Yeah, you're right.
I did not get it.
Maybe I put something like for testing. While testing, I put something like this.
Okay.
Yeah,
I
it
think
is.
you can remove it. You can just check the length or something. That somebody is saying that this to
Yeah.
stop this recursion somewhere, you have to put it like length of L1 is equal to 0, then return false or something.
Yeah.
Or no. Just say L1 if left is less than equal to right only, or left is
Mm-hmm.
greater than, if left is greater than right, return false.
The right is equal
Yeah,
to
got it.
none.
Which one?
If right is equal to none, then return -1 or something like that.
But right, will it go there?
If if the array is empty, the right will be equal. There will be no right. Both
But
will
no right, that means return -1.
Yeah, it was do one thing. Say if right is greater than left, sorry, left is greater than right, return false. Left is greater than right, return false. Return false. What else could be a scenario? This other scenario could be that, okay, right. Yeah, this is correct.
Actually, I
Okay.
don't think the statement is required. If left greater than right, returns.
Yeah, she has already done it. She has already done it.
Because there's an else statement. If left is less than right, it's going inside the if statement. If not,
Yeah.
it's
And
coming.
do one more thing, Sweta. I think that left less than equal to right.
Yeah.
Yeah.
This condition will capture.
Or just remove these two lines, line number 6, line number 7. These two lines, that's it. Delete that. And say left less than equal to right. Line number 8. Okay. Why I'm saying it, I'll show you. Or just remove it, I'll show you what's wrong with this. Okay. Let's just test it out. Okay. Just define the binary search method. Define binary search method. Say def binary search and take L1 and number. L1 and number. Okay. And return underscore binary search. Okay, call that. Yeah. Perfect. Perfect. Yeah, test it out. Okay.
Because it is different.
Now you can test. Yeah, now you can test the binary search method. Though your search spelling is wrong, but that's okay.
No,
No,
line
recursion
number
name,
15. Line number 15, it is
line
coming.
number 15 and 17. Method
15 and
name.
17 has to be removed to underscore by research.
Oh yeah. She had changed the name of those functions. That function. No, line number
Did I miss
16
something,
and
sir?
16, 17, 16, 18.
Okay.
Yes. Okay, test it out now. Okay, just say rather than L1, just put the array here itself so that we can quickly test. Okay. Okay. Now, yeah, just print this. Okay, let's see. Comment out the next thing. Comment out all the code if true and false.
I think you have to run that cell first.
Error cell first.
Run that code first.
We are not printing anything out, but
Run the 64 number of cell.
Okay, perfect. See, you are getting good practice. In the interview, the interviewer will be looking at your code just like this, and you have to handle that stress. Okay. I remember, like, I've seen many people, they blank out when somebody is looking at their code. Okay. But this is good stuff. Okay. I think, yeah. All right. All right. Super happy. Okay. All right.
it's
Yeah.
showing
Yeah.
false.
What? Is it working?
It's showing false actually.
Exactly.
Why is there? Yeah.
Yeah, you have to say left less than equal to right. Okay. Just say left less than equal to right. Because what is happening is when it's going in recursion, okay? Yeah.
Yeah.
Just do that thing. Because at the point when it is dividing, only one element is left, this will fail. When left and right are equal, okay? Can you go back and revert back your code to less than right? I'll show you. Okay. Test it with one element. Okay. Okay. Go up. Just revert back your code to that one. Yeah. Now just search with only one element. If array has only one element, can you search on? Array has only one element, 8. Just put only one element, 8. Now test. Yeah. See that? What's happening is left and right are at the same position. So mid is supposed to be there. And if your logic says left has to be less than right. Correct?
Yes, sir.
Got it? That's why you just have to change that logic. All right, very good. I hope you got the idea. Anybody has doubts on this approach? Good work, Vasik. Very good. Okay. Rupam, you got the answer? No? Perfect. Very good. Very good. Now, the next question was with respect to, you have a list of zeros and ones. Okay. And Rahul, I want you to answer, or anybody else wants to, this question. You have a list of zeros and ones. Find the count of zeros. The array is sorted. How would you do it? You have to find this location where the element to the right is 1 and this is 0. Okay. Anybody wants to volunteer? Has anybody tried this, coding this?
Yeah. Yeah.
I think I'll take typical for loop with the length of array and run two
Okay.
variables I and j. I would
Okay.
be like 0 and
Define count zeros. Okay.
yes.
And the problem statement is this one. I'll just copy this to a new notebook today. Okay, let's everyone work with me, please, and help me write the code along with Rahul. Okay, this is important. Okay, so I'm saying define count zeros. Okay, one strategy we discussed yesterday was go from left to right. Okay, and find count all of them, but that's order of n, that's slower, right? So we want to make it really fast, and it is guaranteed that it will basically start with zeros and then will come one. It may have no zero there. It could be a scenario that it only has ones. Okay, but if there are zeros, they will be before one. Okay, now how do you go about it? So this is my list. Let's call it capital L, and we need to do that. Now you said you will have something called left equals 0, right equals
length of array
minus 1.
Length of array minus 1. Okay, so we are holding the first element and the second last element. Okay.
Yeah.
And we are saying while loop. You were saying while loop.
Well,
should we just do left less than equal to right?
Yes. Yeah.
Mid equals standard, the same thing that we did for binary
divide
search.
by 2. Yeah.
Divide by 2. And we are computing the integer because we want to say that, okay, like.
Yeah, it's the number. Yeah.
Okay. Now we are saying if, now this is the most critical part. Okay. This is the most critical part. And it is guaranteed, I can tell all of you that it is guaranteed if you are going for any top company, one of such problems will be asked in initial rounds. Okay. And this is the most critical interviews. Okay. This is the most critical interview. Okay. Now, if the list L at mid, okay, what are we going to check?
So if L mid minus 1 is 0, and
is equal to
L
0.
mid equal to 1, then we can
if this mid minus 1 equals to 0, okay. Rahul, I think I'll let Rahul take the decision. Rahul?
Yep.
Go ahead. Yep.
So that's right. L mid minus 1 equals to 0.
Mid minus 1 equals to 0.
Equals to. Yeah.
Okay.
And mid is 1, then.
And L of mid equals 1.
To 1. Then it's all sorted, right? This is what. So return. Yeah, true.
Return
return 2 numbers, right? Like mid and mid minus 1, basically. Yeah.
So should we return mid or mid minus 1?
Both, I guess. Because that's the position we want to understand, right? Like,
which one? Mid or mid minus
1? I mean, I'll
just choose one.
I'll go with mid. Yeah.
You'll go with mid. Basically, you are saying that if mid minus 1 is 0 and mid is 1, so you are here.
1.
Yeah.
Yep.
So you're returning the first occurrence of 1, correct?
1. Yep.
Okay. Now that's good. Next.
But else if 0, 0 or 1, 1, then yeah. So let's say if it's L if mid minus 1 and
if
L if, yeah. else if.
So here instead of counting zeros, you are returning search index of
Malicious. Yep.
boundary, right?
Yep.
You are returning the index of the boundary. Where is this boundary found? Correct?
Yep.
Or search first one. Okay, wherever the first one is encountered, you are returning that location, right?
Location. Yep.
Or I'll just make it more explicit. The naming is very important. That gives you a thought clarity. Okay, so we are finding the first occurrence of one. Okay, so you have returned here. Okay, now is there an else?
Yeah, if mid minus 1, I mean, if mid equals to 0,
Else
could be also be the case, right? If mid equals to 0, then
if
no, wait, 0, 0, yeah, 1. What if mid equals to 0 then? If equals to 0, then
Okay.
you need to go right.
Okay.
Actually.
Let me make it this. Okay, let me make it this way. Okay, so if okay, let me see if I can help. So what we will do is there are many scenarios here. Okay, many scenarios. First scenario is you are here. Okay,
Yep.
there are many scenarios. This is one scenario is this that you are here. The other scenario is that you are here. Other scenario is that you are here and you are here. Okay.
Yep.
You are at 0. Okay. So, right. So first scenario is you are at 1 or you are at 0. Okay. So either the location of mid could be 0, location of mid could be 1. Okay. If it is 0, what do you want to do?
If it's 0, we have to navigate right? So I'll make left
Okay.
equals.
Okay, let's do that then. First, we'll remove this and we'll just start with if L of mid is equal to 0, meaning we are on any of these locations. Okay. If
Yeah.
that occurs, what you want to do? You want to only search on the other side, correct?
Right side. I don't want to go left. Yeah.
You don't want here, let's say you're here, so you want to search from the next to this. So you will say left equals to mid plus 1.
Mid.
Yeah. Now,
Yep.
else. Now, this thing, let's say you are at, yeah.
I mean, if mid equals to 1, then I want to traverse left, right? So,
Okay.
then I'll make, yeah.
Okay, go ahead. Now, we are in else right now. Okay.
If L mid equals to 1.
Yes. That anyway is guaranteed. If we are not, this is not 1, then L of mid is 1.
Yeah.
Correct?
Yeah.
So right now, we find that at the mid position, we are at 1. Now
left will remain 0 and right would be your mid.
Right would be mid minus 1.
no, I mean, we have to find if mid equals to 0, okay, we return mid. That could be one scenario. If let's say we are having a situation where you have only this list and you are here, okay, that means you just return, right? That could be scenario, right? So we said L of mid is 1, not 0. Either it could be this. Okay, so if the middle, the beginning of the array, the return mid. Okay, we have found the corner. Else, okay, else. Now you could do now. Pay attention. Now, else as in, now mid is not 0. First element, it's not first element. Okay. It's not first element. It could be, scenario could be this. Okay. Scenario could be this, right? Scenario could be this, that we are here. Either we are here or we are here. Okay. Correct? So we are at mid equals L of mid equals 1. That could be at the border or that could be somewhere else. Correct? So we are saying else if we are not at the beginning, there could be two scenarios. One, we have arrived. Second, we are somewhere on the right. Correct? So we say, okay, we say else if L of mid minus 1, okay, L of mid minus 1 equals 0, return mid. That means we have found it. Correct? That means we have found it. Okay. Else right equals mid minus 1. Are you guys convinced? Or does my logic looks very crazy? No?
That's fine, Sandeep.
Looks good?
Yep.
So we covered the case where the mid could be at the beginning. Okay. Let's take a look. So we'll right now we are just searching for the first index of okay. We'll just write, I'll write my assert method. Okay. I'll just say test cases, test underscore cases. Okay. And I'm going to write this array of tuples. Okay. So what is it about? We are saying in case we are saying this, okay, our expected result is what is our expected result? 1. What should we return in this case? This case, we are clear that it should return 1, right? In this case, what should do you want to return? 0. Is it okay? We are returning the boundary. Okay. So I'm just writing the test cases and we will write the validation of test cases method. Okay. So give me more test cases.
In if
So only 0 is there or only 1 is there?
Yes.
Only 1 0.
Only 1 0. Okay, that also. In this case, what do you want to return? Where would you return the location of first one?
0 numbers.
What?
If there is only 0, like only one element is there, either 0 or either 1.
Okay. What should I do in this case? If
0.
left is greater than, we have capped on going to the right. Okay. What should we return in this case? This is hard. Okay. Let's see.
length of the array.
Actually, why don't we do one condition in the very beginning that if the length of array last element minus 1 is also 0, the whole array is 0, right?
Yes.
We'll avoid actually testing this scenario.
Okay. Okay.
In that case, we can return -1.
That's
Okay. No, I think let's just write the test cases as if we are going to break the code. Okay.
Okay. Yeah.
Okay. Let's write the test cases first. We call it test-driven development, where we write the test cases first and then write the code. Okay.
Empty string, empty array.
Empty array. What do you want to return in this case? -1.
For 0.
Okay. You want to return 0? 0 means that we have found it here.
There is the main
We are returning number of zeros, right? So 0 makes sense.
number of
There is zero
zeros.
zeros.
We are saying
Count
find the
zero.
first one. Find the first one.
Okay. Oh, find the first. Oh, sorry. I thought
Yeah,
it
what we
was.
will do is we will basically at the end of day we want to count how many zeros are there. Okay, we want to count how many zeros are there. For which what we have written is we have written a logic that which will find the boundary. Okay,
Yeah, it
in the
makes sense.
boundary we are returning where the one starts.
Mhm.
Okay, either we could return where 0 ends. Okay, or we could return where 1
One
starts.
starts.
Okay.
Yeah.
So if we were doing 0 ends, then we would be returning 0 here, and we'll be returning -1 here. We would be returning 2 here, 0, 1, 2. Okay. So it'll be 1 lesser. Okay. Now,
single zero array with single zero and single one.
this one should return 0, right? Yeah. No, I think. Question is, which one does make sense to you? Find the first one or find the last 0? Should we do find last 0?
Yeah,
Last 0.
find last 0 and we give.
Okay, let's do the find last 0 and see if we can. It'll be interesting to notice that these small things make a lot of difference. Okay, so we say left equals to 0, while left we keep on going. If L of mid equals 1, okay, we simply say that the right equals to mid -1, right equals to mid -1, else, okay, else if
Can we make it not equal to 0? Because it can be a scenario like zeros and only 1.1, 1.2, like that also can come, right? So if it is not equal to 0, L of mid equal to 1 is what? Line number 6.
line number 6, okay, go ahead.
Can we make it not equal to 0? Like if it should not be like it should be always 1. You can have different numbers as well, right? Other than 0.
Okay, that's also good. That's also good. We can basically utilize it for our next problem statement, right? That's what you're looking for.
Yes.
Okay, we'll do that later. So we are saying now that if this value is not 0, just go to the left, find the last 0. Now, if it is 0, now we are going to check, is it the last 0? How would we check? Is this the full array? Have we reached the end of the array? So we're just checking mid equals to length of L -1. Okay, just to be sure, doubly sure, I'm putting a bracket. Otherwise, let's say this is not the last element. Okay, what we do is we say, we check if the value on the right is not equal to 0, okay, meaning value on the right of my mid value is 0, is not equal to 0, meaning 1, okay. If this is the case, we are at the last 0. Otherwise, we are here and we are going to say left equals to mid +1. Okay, meaning we are somewhere in the midway of zeros, so go and search in the right side. Okay, all right, this is finding the last 0.
Can we have one more condition in if, because if we check left of mid -1 is 0, then we can also exit at that time, or we will have to recurse one more time.
Come again?
In if condition, can we have one more condition where we are checking left of mid -1 is 0, then we can exit at that time only. So we don't need to loop again.
Yeah, for the third test case, if all the elements are 0 in an array.
if all the elements are 0, right?
That's
So
what I.
let's see, will this code work? Okay, right? Initially, it will jump here. Okay, right? This will jump here. It will come here. Is this not equal to 0? False. It will come here. Is it last element? No. It will come here. That is this value not equal to next one is not equal to 0? Then it'll come here, right? So it will go and search in this here, correct? It'll basically say left equals
I mean,
to
it's simple, right? Like if your left is 0 and
no,
right is
it'll
0,
go and search
then
here, right? So left and right will become the last element, okay? And then it'll come left and right is equal to 2, so it'll come here, okay? Check, is it right? Mid value is not equal to 0, false. It'll come here saying mid is equal to last element. That's true. So it'll return the last value. So this third test case is making sense, right, to everyone?
I mean, third, I mean, you can check it initially, right? If left is 0 and your right is also 0, then
They
you
avoid
exit the
iterations.
condition, right? Like basically, you are only
I don't want
going
to
I mean,
pre-optimize.
you
I just
only
Okay.
you are going into the loop if your mid value is coming as 1
okay.
initially, right?
So Rahul, I will tell you, and I think this is a very important lesson for all of us, that the focus is on correction. Okay, though having this monkey on your shoulder telling you to optimize all the time is a good idea, but
Yep.
the problem with binary search is getting it right. Okay, problem is not the performance. Performance of binary search is going to be any day better than every other approach. Okay, so focus is on correctness. Okay, I don't want to make mistake, and you will be amazed to see how many mistakes we'll make. Okay, let's see. Should we test it? Okay, I'll write my tester. It take test cases. Okay, and runs them. It says for test case in test cases. Okay, and it'll say array comma number equals test case. Okay, this is a tuple. Tuple you can assign. You know that like a comma b equals 1 comma 2 comma 3 and 4. So you can assign it like this. A will become 1 1 2 3. B will become 4. Okay, this is clear to everybody. So you can assign the tuple values to two values. Okay, so you can essentially, this is like tuple assignment. Okay. Similarly, in Python, you can also do a comma b like this, and you can assign, array of values to a comma b. Okay, so a becomes 2 and b becomes 3. You see that? Okay, so similarly, tuple is round brackets, and this one is a square brackets, the list.
Yep.
Okay,
So here
so
ARR variable becomes your
yes,
array that you are
ARR will
passing.
become this, number will become this. Okay.
Yep.
And we say print. Okay. Print. What is that value? We will just print what is that ARR, and then we'll print colon, and then we'll say what is the name of our function? I'll delete all the junk for now.
Last.
Okay. And find last 0. Find last 0, pass the array to it, and run it. Okay, let's run our tester on these test cases. Okay, what does it say? Find last 0 is not defined. Again, I'll run it. Okay, all right. So also what we can do is I can say num equals this. Okay, so in this case, it is true. Okay, or we can also say if num equals to this, no. I'll do a better job. Okay, I'll say return value, okay, actual value is this, and this is expected value, okay, okay, and if
Actual equals to
actual equals expected, okay, print right, success, okay, like we're just printing success. Usually you don't print success, you only print failures in real life. Yeah, so I'm saying this is success, okay, else print failed, and anyway, I'll just say print testing array, okay. In case it is success, I'm printing it just success, okay, and otherwise I'll say failed, and I'll say expected. What is the value we expected? We expected this, but got this. What is that? Got actual. Okay. I'll just put F in front of this, and that's about it. Okay. So what you see here is a very important part. Where did I make mistake, everyone? Yeah. Okay. So what? Yeah. So testing 0, 0, 1. I'll also put like tab. That way it'll look nicer. Okay. I'm just putting /t. /t means tab. Yeah. So testing 0, 1, 1, right? In this case, it is success. And here it says expected -1, but got none. Okay. Now, why is that? Okay. Why is that? Okay. So there would be a scenario when left is less than equal to right. Okay. When left is greater than equal to right, which means that it kept on looking for values. Okay. Let's say we are looking for last 0, right? We are looking for last zeros. Okay. So in this case, what will happen? Right will become -1, correct? Right will become -1 because it will come here. Okay. The moment it sees 1, it'll keep on going to the left, and there'll be a point where right will become -1, correct? So there could be one scenario where right became -1, okay? And there could be another scenario where left, okay, became bigger than the right. When would that happen? When would that happen? When it is probably empty, correct? No. So left is 0. Let's say in case of empty, left will be 0, right will be -1. Okay, right will be -1. Okay, and that is one scenario. When will this loop exit? Okay, so in this case, right, loop will be successful. In this case, what will happen to the right? Right will be -1. Okay, and in this case, okay, so let's see if returning right makes sense. Okay, all right, here, okay, what happened to this code? Why did it not return. It says that it returned, this failed, I got none. Why did it happen? Okay. Why did it return none? Where is it returning none?
I
Anyone?
think it
Also,
should
one
return
scenario
in a-
we didn't check. If left equal to right, then I think if one element is there in
Yes.
array, then I
Yes.
think there is no exit.
That's okay, no? If
No, I'm
if
not sure whether. No, suppose I'm not talking about this case. Suppose in the array there is only 0 or only 1, then what will go? Will go into the loop, but when will come back? Exit?
okay, okay, that's okay. I mean, I think that particular case should be covered in this logic itself.
Not sure.
See, if there is only 1 0, that is covered. Okay, you can test it out. That is covered. You can just test it out. Okay. If let's say there is only 1 0, okay, it should return this. Okay.
And also on 1 1, you can check.
If there is only 1 1, okay, there is only 1 1, okay, it should return 0. Okay, what happened here? I just have to put 1 comma. Okay. So this is successful. This is all are successful.
Only 1 is also returning success.
Everything is successful. Okay.
If you go into that while loop, there we can stress that there is no exit for one element. If left equal to right, I think. Just go up later.
No, I'm just thinking that, okay, let's just put the test case now here. Let's put the test case now. So it is all of them are successful, by the way. You see that?
Yeah.
Okay. Everyone, am I making sense?
Why was it printing none earlier, Sandeep?
I don't know where, probably I did not execute this one. That's why it was doing that. I think I forgot to run it, this code.
Oh.
Okay. So this looks good, right? Mm-hmm. Anybody wants to try more?
Sir, in case any other number other than 0 and 1?
Now I'm just trying to see, let's say 100 plus 1 and say 200. Okay. And the answer to this one should be last, right? Last, there are 100 zeros, so it should be 99. Okay, yeah, that's also successful. Okay. So I tried with 100 zeros and then 1, and that also worked fine. So all are 0, all are 1. There is only 1 0, there is only 1 1, there is only empty, then there are 100 zeros, 200 ones. And then there are these kind of numbers just to check. And this seems to be okay to me. Does anybody wants to, put more test cases? Okay.
If you do not want to binary search, then we can have a simpler solution.
Now what?
If you do not want to use binary search, if you just want count number of zeros, then there can be simpler solution.
There could be very simple. It'll be like one liner. I could just say sum of the array, right? Sum of the array and then minus, sorry, count
Minus sum.
count of the array minus sum. right?
If we can use the above binary search that we already made.
Now,
we
why
can
did we
use
use the binary search? Any reason?
For the efficiency part.
Correct.
time
So,
complexity login.
yes. So here is a very, very trivial question. So you have two approaches. Approach one, okay, is sum, sorry, count minus sum, okay, count minus sum, that is right. That is one approach, okay. The second approach is binary search, okay. Now question is, right, what is the the performance of each? This one is order of n, this one is order of log n. Okay, now what difference does it make? Okay, so let's take a look. If there are 1,000 element and it takes 1 milliseconds, right? For 1 million elements, okay, for 1 million elements, it will take how many seconds? How many milliseconds?
1 million.
Again, 1,000 seconds, right?
1,000
1,000.
milliseconds.
Oh,
1,000
okay.
milliseconds.
1,000
It will
seconds.
be 1 second,
Oh, yeah.
right?
Yes.
Or I'll just say 1,000 milliseconds. Now, in this case, if you have, okay, or okay, here, if it is log n, right? So log n. So approximate, if in case of 1,000, it is taking 1 milliseconds in binary search. Of course, it will take very less time. Okay, 1 milliseconds. For 1 million elements, how many time will it take? 2 milliseconds. You see the difference? 1,000 versus 2 milliseconds. You got the answer? Everyone?
Yep.
Are you convinced that am I making sense?
But Sandeep, like if the array is not sorted, then
Yes. Then it
there will
doesn't
be
make sense.
then
So
the complexity will change, right?
yes.
Because
But if
in
you have to do
sorting
the
the array,
binary search over and over, like hundreds of times, what do? You will sort the
We have to
array
sort
first
the array first.
and then call it. Okay. We'll talk about this soon when we talk about sorting algorithms.
Yeah.
okay.
Yeah. Binary
Sandeep,
search is all about, working on a sorted array, right? Like,
Yeah.
yeah, the array has to
Now,
be sorted. That's kind of a prereq, right? Like to do binary
yeah.
search to work.
Yeah. Now let's change the problem a little bit. Okay. So this is if 1,000 element is taking 1 second or 10 element, let's just say 10 element is taking 1 second. Okay. To search in 10 elements, it's taking 1 second, though it doesn't look good. Let's just say to search for 10 in 10 elements is taking 1 milliseconds. Okay. 100 will take right 10 milliseconds, 1,000, okay. Say 100 square, let's say 100 square, how much is that? Will take how much? Okay,
1,000 milliseconds.
1,000 milliseconds. Okay, million. Okay, 1 million. 100,000 milliseconds and 1 billion elements is going to take how much? 100 million seconds. Okay. And here, let's take a look at the same problem statement. Let's just say here, okay, in case of binary. These are very important to feel it. I want you guys to feel the difference between binary search and normal work. Okay, it's an extremely important thing to solve. Okay, now 10, let's say searching using binary search in 10 elements is taking 1 milliseconds. 10 square will take 2 milliseconds, right? And 100 square will take 4 milliseconds, correct? And then 1 million elements is essentially 10 to the power 6. So it will take 6 milliseconds, okay? And 1 billion elements will take 9 milliseconds. Compare 100 million milliseconds with 9 milliseconds. Does it look realistic to you?
Yeah.
Okay. If you want to do the test right away, I'm ready to do the test right away. Okay. Let's say we create the array.
Lesser, right? It's in the lesser than this. Now we have taken log based, then it should be log based too, right? Then it should be even more lesser, I think. No?
No, I mean, it's a proportional, right? So we are saying, okay, we are saying time equal to log 10 or 2, it's the same thing. Okay.
Okay.
T1, right? T1 divided by T2 is equal to N1 divided by log of N2, correct? That base 2 will cancel out, okay? Base 2 will cancel out. Now, okay, let's take a look at this calculation, okay? Let's take a look at this calculation, okay? Our T2 was, say, how much? 1 milliseconds, okay? How many elements were there? 10. N2 was 10. Now N1, or let me just to make sure we are, T1 was 1 milliseconds. N1 was 10. Okay. Now N2 is how much? 1 billion. So 10 to the power 9. That's right. Correct? So how much will be this? 1 divided by 9. Okay. So T2 equals to 9 milliseconds. Got it?
Okay.
Right? Even if it's log 2 or log 10, doesn't make sense. If it was log 2, let's say, right? Still, this will remain log 2 and this will become 9 log 2 of 10. And that log 2 of 10 will cancel out and you'll get the same answer. Got it? All right. Now, you see the difference? You have here, it is taking 100 million seconds. And this one is taking 9 milliseconds. Now tell me the magnitude.
100 milliseconds.
Yeah?
Line number 7 is
100 million
milliseconds.
milliseconds. Yeah? Okay. Which is going to be how much? 100 times 1000 seconds. Okay. Which will be 100 times 1000 divided by 60 minutes divided by these many hours. Okay. So, all right. So these many hours. Okay. So the normal one is taking 27 hours and this one is taking 9 milliseconds. Doesn't it look like a joke?
Yeah, Sandeep, a small question here in approach to 10,000 should take 4 milliseconds, right?
10,000 should take 4 milliseconds. Thank you.
Okay, I was confused. Thank you.
10,000 should take 4 milliseconds. Am I making sense, everyone?
Also, Sandeep, in the approach one, it will only work if the arrays have only 0 and 1. So it's not kind of generic as well, right? While the binary search can work with if we have 1, 2, or whatever kind of elements.
Correct. No, I mean, even if you write a for loop one, okay, if you write a for loop one, okay, like the one that we discussed yesterday, we go from left to right. The for loop will also have the same kind of time complexity.
Efficient complex.
Yes. Okay. All right. Make sense, everyone? Is everybody with me on this so far? Do you want to test it out in case I'm lying? Okay. So let's say I'm saying, give me, say, 500,000 elements. Okay. And then I have one, and this is, let's say 500,000 elements, 500,000 elements. Okay. Now I have this loop approach. Okay, I'm saying array. Madhumita, there's a noise coming from your side. Okay. I'm saying count array minus sum of array. Okay. So let's say I'm calling it on this array. Okay. I'll just call it large array. Okay. Just to avoid the confusion. Okay. And right, I could say, all right, count is not found. Where? Okay, length, not count. Okay. So this and it fast. Okay, I'll just increase one more here. It is taking a still reasonable size. Now let's go. All right. It took fair amount of time. Do you want me to test it with more numbers? Okay, it's going on. All right. How do you time it? Using a function called time it. Okay. Now let's just do the binary search on this number. Okay. Memory error. So we'll have to reduce the numbers. Okay. Okay. Binary search on the large array. Okay. Where is our binary search? What was the name of the function? We called it. Where is that function?
Find last zero. Find last zero.
Find last zero. Okay. Quick. Right. Basically, we are returning the index. So if we just add one to it, that's it. Correct? Okay. So the time it takes is just very, very amazingly fast. Okay. And that one is taking too much time. You can see it's still running, it's still running, it's still running, it's still running. Or what I can do is I can just say interrupt. Okay. Separate these two cells into separate cells. Okay. So that this memory allocation is separated out. So it's taking time to allocate the memory. Okay, now here I'm running it. You can see that it's taking time, right? Okay, and this one is quick. Okay, so you can actually use time it. There is a library called time it. Okay, let the first one finish. No, first one is still taking a lot of time. In the meantime, I can just go and search for
It's
Time it.
percentage time it, right? It should.
Okay. Okay, time it. Okay, so you can actually just put the logic in this. Oh, you can actually write the code in this. Okay. Will it work? All right. Yeah. So this one took 4 seconds. Okay. Notice this. This one took 4 seconds and this one took 8 microseconds. You see that, everyone? Hello?
Yes, Sandeep.
Hello?
Yes, Sandeep.
Yes, yes.
Are you impressed with your binary search?
Can you please divide the first one by second? Time.
Huh?
Divide the first time by second.
Okay, it's like 1 million times or so. Okay. So yeah. All right. So you can essentially see the effect. So this calculation that we are doing, it's not a hypothetical calculation. This is real. This is real. And the magnitude of change, the magnitude, as the numbers become larger and larger, binary search starts showing the quality of the speed. Okay. So while if somebody wrote this code, okay, they'll say, oh man, the Python is slow and we need a better programming language to make it faster. But the reality is all they need is better engineers to think in the research.
Can think better.
Yeah.
Yeah.
So that's a very, very important thing. Okay. And this is what I have seen in past. Okay. So all right. Okay, let me see. Omdat, are you convinced? Yeah.
Yeah, I'm 100%.
Okay.
Sir, I posted one solution. Can you please look at
Okay.
the chat?
Why don't you share your screen?
Okay.
Okay. It's a very important exercise what we are doing. Okay. It's this is something that is really, really helping many people. Okay. I'm not seeing Neil today. Where is Neil? Okay. All right. All right. Everybody, do not take binary search lightly. The same code that we wrote today, finding the last zero, I can guarantee that you will get it wrong in the first shot. Okay. So spend good time. Okay. Spend good time. Honestly, good time. Okay. Struggle with it. Don't give up. Struggle. Try all kinds of ifs and else and this boundary condition, that boundary condition. Try everything. Debug like crazy. Put print statements everywhere. Put everything everywhere. Do not wait for the solution. Okay. There is no such thing called right or wrong. You don't need an approval from me for right and wrong. You can do the calculation of complexity. You can do the calculation of complexity that tells your complexity. You can write your test cases that tells the correctness. And these are the only two things matter. The correctness and the complexity. Okay? Correctness and the complexity. Okay? Complexity in terms of memory, complexity in terms of, okay? These are the only two things that matter. Okay. Okay, perfect. So count of 0. So you are saying left and right is perfect. If length of array is equals to 0, you are returning 0. Okay. While left is less than equal to 0, you are going to the mid. If can you just check my test cases? I'm copy pasting the test cases for you to you. Okay.
Yeah, sure.
Okay. So first is this tester. I have written tester that you can put tester. Okay, this is my tester code. Then these are my test cases. These are my test cases, and this is how you run it. Okay, yeah, let's do that. Okay. All right, perfect. Okay.
I've done count of 0, Sandeep, so mention that.
You might have to
So
change. You might have to change. This is 1. This is 1. This
Oh,
is
sorry. Yeah, 1.
This is 2. Okay, what I've done? Let me see. Oh, this test case, isn't this wrong? What? I think I made a mistake. Oh. Okay, yeah. I
So
think I
this will
pasted
be 100, no?
1,
Is this
2,
correct?
0, 3. Yes, correct.
So I'll run 1 by 1. Okay. This is my own.
I'm scared.
Yeah. So I think after third, I think it failed for some reason.
Yeah. So when tester was running, where is this LOC variable? It says LOC is not defined. Okay.
I have to do location ultimate B.
You have to be ruthless in testing your own code. You don't have to be nicer to yourself.
Yes. Yeah.
Amazing. Walk us through your code. This is very neat code.
So
Okay.
what I'm doing here, so first if length of array is 0, so that definitely it will be 0. Location I've initialized as -1. Now I'm traversing left to right, and the same binary search I'm using. Mid equal to left plus right divided by 2, so it's taking the integral part. Now we have to see the loop is going from left to right in each element. Now I'm just checking if mid equal to 0, and I'm putting the location equal to mid.
Perfect.
And still I haven't stopped searching. So I see that, okay, if location is mid equal to 0, that means still don't have to search left part. Now I do the right part search. So left equal to mid plus 1. So it keeps on searching to the right until it finds the last occurrence of 0.
Perfect.
And else right equal to mid minus 1.
Perfect. Very awesome.
And since it is from 0 index, so I've just incremented 1 for the count of the 0.
Perfect. Awesome code. I really love it. Very good. I'm really happy. This is good. Anybody, any doubts on this?
Tried a recursion code for it.
Huh?
Have tried a recursion code for it.
You are saying you have written the
I've tried
recursive
it with,
code?
yes.
Yeah, it's recursive. It's calling until it's like it's not recursion actually, but it's going
No. He
until
has
left is equal.
He has written the recursive code.
Okay.
Is that Srivatsa?
Is it
Are you
audible?
there? Hello?
No, is it audible?
Now you're audible.
Now it's audible.
I have written a recursive code for this.
Okay.
I also
Sure.
Yeah.
posted it in the
Yeah,
comment.
I saw that. We'll just take a look. Awesome, awesome. Everyone, you like the code? This one, Vivek's code. I really like the code. So what he's doing is he's just tracking the mid location. Every time he is at mid equals to 0, he's saving that location in lock. And basically, when the loop exits, okay, so last seen value of 0 is what is retained in lock. Okay. So basically, the code will exit when it is no longer able to find no longer when the left becomes greater than right. Okay. And just before that, wherever it saw the 0, that will be in the lock. Okay.
Sandeep, then can't we just return the value of left here instead of going all about this creating a lock variable and putting it in mid?
Okay, test it out.
Now, I did make something similar to this. I sent it in chat a while earlier.
Okay. Did it work? Did you test it using the tester code?
I'm not using the tester, but I did run a few test cases. So.
Yeah, do the tester.
Okay.
Okay, do the tester. Okay. Very awesome. Okay. All right. And the initial value of location is -1. If it never encounters a 0, that will be the lock. Okay. Very, very good code. Very good piece of code. Anybody else? You want to show us, Srivatsa? You can share your screen.
Sir, I have tried with binary search using the sum. Instead of just checking, I tried with sum. The sum with the 0 plus 1. So it's greater than 1, then likewise.
Okay. Show me.
Okay, I'm sharing my screen.
Very good.
Sir, is it visible?
Yeah. So you are saying binary search zeros, right?
So I tried with the sum. Instead of just checking mid, I tried with sum with mid and mid plus 1.
Okay. That's also good, but what happens? Can you use my tester and test?
Yes, sir.
Everyone just call me Sandeep. Don't make it this.
Okay.
Yeah, because it becomes inertia from your side next time. So I can be wrong. Like it has to be equal playing field for everyone. So you should have no hesitation in asking questions, having any doubts or questioning in any way. You should be completely free. So don't have that mental block. So that's my request for everybody. Just call me Sandeep. Okay. And yeah.
Okay, sir.
Yeah. Okay, run it. Change. Okay.
I have to take the tester code actually.
Yeah, the test, there was line number 4, the tester code is wrong. So can you correct that code? Correct
number-
the test cases. These. So in case
No.
of, yeah, this one should be 2. And increase everything by 1. Like first one should be 1, second one should be 1, third one should be 2, fourth one should be 0.
0. 3.
And the first one also, can you change? First one.
1.
Yeah. And test.
Yes.
And call your function instead of binary search zeros. Okay. There
Yeah.
in the tester code.
She's not taken the tester code actually.
Okay. Take the tester code from mine. You found it?
Yeah.
Yes. Okay. Change that method to yours.
Yes.
I could just use pass that method as an argument, isn't it? Okay. Okay. Okay.
Is it okay, sir? Or is it
Yeah.
okay, sir?
Go ahead. Go ahead.
Okay.
Okay. All right. What happened there?
Binary search zeros. Your method is that, right? Not testing.
Run the code again. It says testing takes position arguments or something.
0 going on, but 1 was okay. Okay. So it's instead of actually I'm taking array within the.
You have to pass the not the testing inside tester method. You have to pass binary search zeros, I think.
Yeah.
Basically, I've captured 1, 2 test cases in this testing, and then I'll call the binary search.
But you are always hard coding that L1. You are only testing on L1. Correct?
So yeah,
Yeah, clean it up. Clean this code. Clean this code. Pass L1 as argument. Testing should take L1 as argument.
Yeah.
Okay. Just pass L1. Yeah. Okay. See, this is where the mistake happened. Line number 4 is making it order of n. If you see.
Oh yes, sir. Yes, sir. Yes,
Okay.
sir.
And because what it'll do is it'll go in
Searching
search
it.
for looking for 1, and that become order
Order of n and log n.
Similarly, line number 6. Okay. And
Yeah.
so on.
Yeah,
Okay.
and log n.
And that becomes order of n. Okay. But anyway, you test it out. Let's just see. Okay. Again, there you have done twice that thing. Okay. Oh, you're not returning, you're printing. Okay. But anyway, I think you got the point. Okay.
Yeah.
Fix it, and then we'll do that. Very good. Very good. All right. All right. Okay. Very interesting. All right. Perfect. Perfect. I know that I have taken multiple classes on binary search, but I think this is needed. Perfect. Let's move on. And I would expect everybody to try now these other questions that I have mentioned. Okay.
What are those?
What?
No, what questions?
So here, where was that question? Question number 2 is done. Okay. Question number 3. Okay. Now, if you have let's say this kind of sequence, okay, you have to count how many ones are there. Okay. You have to count how many ones are there in a sorted array of numbers. Okay. That is the problem statement. Okay. So what people usually do is they search for this location and then they start counting from here to there. That's wrong. Instead, using one binary search, find this location, use another, find this location, and subtract this from that, and you will find the length. Okay. If you basically find this corner using binary search and then you start going slowly, then you are converting your entire problem into order of n. That is slower. Okay. All right. Is everybody okay with what I'm saying?
Yeah.
Now, the next question was, yeah, this one was another question that I had given. And okay, this one was another question that you have 100 numbers. Okay. And okay. All right. Now, I want to give a couple of more questions so that you give it a try. Okay. The question was, you have increasing and then decreasing numbers. Okay. All right. Find the maximum value. Okay. Meaning you have a sequence, let's say 1, 2, 3, 4, and then 3, 2.5, 1.5, minus 2. Okay. So this is the number and you have to find the max value. How would you find the max value? Okay. All right. Similarly, there could be another variant. Okay. This is called like a sequence like, so this is a sequence like this. Okay. You have here, what do you call this? This is called convex or something. Right, this. Okay. You have a sequence like this, it increases and then goes down. Okay. You have to find this max value. Okay. Now you have a decreasing and then increasing numbers. Okay. Find the minimum value. Okay. Now, both of these problems might look very obvious that we'll just apply the for loop, go from left to right. That's it. But you are not utilizing the property of this list, where this list first increases and then decreases. Okay, so use binary search. Okay, nobody will tell you that use binary search. They will say you have an increasing and decreasing number sequence where first the numbers increase and then it start decreasing. You have to find the max value. Okay, so first obvious approach will be that you will write a linear way that, okay, go from left to right, keep on going, and the moment you hit the max value, right, you stop. So your problem statement basically will go only till the midpoint and then you stop the moment it starts decreasing. Okay, now at this point of time, your order, your complexity will be order of n. And here, if you basically, similarly here, the complexity would become order of n. So use the binary search. Binary search will make it faster. Okay.
It's similar to a step in quicksort that we find a pivot element, and on the left of it, all the elements are less than that.
Yeah. Yeah. Okay. So will you be able to code both of these?
Okay.
Okay.
Sandeep, just I think a very basic question. Can we access your notebooks? Like, I guess, yes,
Oh,
right?
thank you. Thank you for reminding. I will just commit it here. Okay. I will just commit it right away before it is too late. Okay. So it is Python IITR April CD Python IITR April Git status. Okay, it says that this one has been modified. So I'm saying git commit. Okay, new updates. Okay, and this one has not been committed, so I can just commit it, git add. Okay. Just okay, so I have pushed it to the repository. You can take a look. What was that repository? This one. Yeah, everyone? Are you able to? You can say git clone. Yes. Okay. You have a set of number in an array. Find
Yes, yes, sir.
duplicates.
So you have given this question yesterday's class. So actually, is this we can do it by binary search or another approach? If it is binary search, so I'm not getting
No,
how we
no,
can do
no,
it.
it's not. It's not binary. It can't be done with the binary search. Okay.
Okay.
This is sorting data. It's not nothing to do with you. It was somebody else who was asking. Okay. We'll talk about it very soon. Okay.
Okay, okay.
All right. All right.
So
Yes.
can I share and show something? I have a doubt there. Just share. So it's about what will be the complexity in each case. So this was one, I think it's visible. Is it visible?
Yes. Yes.
So this was one question. You have 100 numbers or million numbers, second list, and you have to find the common numbers. So I
Yes.
tried various methods. So which one is the appropriate one? So one is return. I can make it as a set and intersection with the other one. That's a like inbuilt function. So I'm using that. I think it will be order of n. Is it order of n? I tried various methods. I think these are the complexities. Is it right or wrong? That's my question.
No, it won't be order of n. Okay. We'll talk about this. Don't worry. We'll talk about this.
Okay, this will be order of n square, right?
So this set is a hash set underneath, so it will be order of n. Yes, order of n and m. If n is there, order of n, and then you have it'll be order of n plus m kind of thing. Okay.
So instead of going for a binary search, which will be n log n, we can go for this, right? Order of n is much better than n log n.
We will talk about this.
Okay.
Okay. This one is mandatorily in the memory operation. Okay. And you cannot like I'll talk about this, don't worry.
Okay.
Okay. All right. This is good stuff. And yes. All right. So with this, I would say that everyone do as many questions as possible on binary search. Wherever you find, whatever you find, put your heart into it and try coding it up. Recursion and binary search, these two are kind of not common sense. These are not common sense. Like if somebody asks you that order of n, if you tell somebody that order of n is taking 27 hours and binary search is taking 9 milliseconds, okay, so it is not common sense. It's not common sense at all. It's the common sense doesn't allow that kind of magnitude of change.
What was the second question that you have asked? In currently you have asked, right? In the increasing and decreasing
Yes.
area one. So what is the
Yes.
second question in that?
Second question is yeah. So you have to find the minimum value. Okay.
Okay.
Yeah.
Got
Let me share my screen. Okay. I think I made a mistake here. Okay. This is supposed to be, let's say, 100, 10, 5, 0, -2, 1, 3, 5, 1,000, 3,000. Okay, so this should give you the answer is -2. In this case, the answer is 4. Okay, and I'll just commit it again. All right. But Git status. Okay. All right. I will, yeah. Perfect. So I would request everybody to just start working as much as possible on binary search, and and then what I will do is we will go over the dictionary, we'll go over the tuples, and then we will come back and talk about searching and hashing. Those will be the next ideas. And then we'll go over classes and objects, and then we'll talk about the data structures like trees and other things. Okay. So it's very important and very critical for everybody to feel the algorithms and data structures. Okay, so it's very, very important. I know that I can't cover each and everything in these classes, but I can just do the one that is not common sense. Rest of the things you should be able to figure it out. Okay, so yeah, that is the core idea. And second is don't only rely on these classes. My request to everybody would be, say, take a subscription of Lead Code or take a subscription of some other service, or just start competing in online contest where you just do the coding. That would improve your overall muscle, right? This is at the end of the day, just like gym, the more you practice, the better you get. Okay, there is no such thing as universal intelligence. Nobody's born with this logic. Okay, nobody's born with this logic. If somebody's telling me that there are child prodigies and all of that, that's absolute nonsense. Okay, I believe that it's all a matter of practice. Okay, just a matter of practice. Okay, so don't think about anything else. Just focus more and more on practicing. The more you practice, the better you get. Simple. Okay, there's no other thought. There's nothing else. All right. Thank you, everyone.
Yeah, sorry, just one last question. Is there anything like time it to know the space complexity also, like space it or something? Because all the time we are worried about time complexity, right? So I'm just curious if there is
Yeah.
something.
No, time it will not tell you anything. Okay. Time it
No.
only tell
For
you
space complexity also, is there any inbuilt function that
you will see, you saw that memory overflow. That is a good
that is
sign.
only indication.
Yeah. Similarly, time it is also like that kind of indication, but you should be able to count it. You can see that, okay, here we are creating one array on every loop. It's going to overflow.
Yeah, so we are always concerned only about time, right? My question is space complexity.
Both.
Okay.
Both. You have to keep in mind. If you see that every time somebody is allocating an array, that you should be alarmed that, oh, there's a loop, and then within loop, and we are creating more and more recursively, it's going to overflow everything. Okay. So have to, keep that in mind. Okay. So we'll talk about more space complexity when we talk about sorting and searching, then you will like. Okay.
Thank you.
There is Spark application will, yes, thank you, Samip. That's very right. When you have like data engineering issues everywhere, it's essentially when you can't fit things into memory, this is where the problem starts. Okay. And most of like you have to be aware. Okay. Like the way you see the yoga guys, yoga guru telling you that you have to be aware of your breath, and like that, you have to be aware of your loops and your memory. Okay. Deepak's question is, what's a Spark? It's a data engineering tool. So what is Spark? In simple words, it lets you sort data using multiple computers. Okay. It's basically in a very glamorized sorting machine, but it's a little more than that. I'll talk about that probably later. Okay. So once you are clear once you have this feel of data structures, algorithms, and complexity, then I think you won't have any problem dealing with any data structure related problems. Okay, any big data things and everything. Okay, the things are much more simpler than they look. Okay, and that's why I mean, once these fundamentals are very clear, you'll be able to just handle most of the scenarios easily. Okay, you don't have to teach each and everything to you. Okay. Perfect. Wonderful. I'm super impressed with the class. I'm very happy that all of you are working with me. I want everybody to work with me. I mean, nobody should be left behind. If you are feeling left behind, reach out to me. I will make sure that I'll catch you up or figure out some way to bring you all up to the speed. Okay. Work hard with me, and I mean, it'll pay in long run. All right. Thank you, everyone. Have a good day.